Welcome to this session. And in this session, we will discuss heat equation with non-homogeneous boundary condition. What do I mean by that? So, as you are already familiar with the equation, del U over del T equals C del U del 2 over U del x2. Okay. For 0 less than x less than L, and T has to be greater than 0. So, you already know that in standard heat equation, we generally take U02 to be 0 and ULT to be equals 0, right? This is what we have seen because in our previous video also I have discussed about this, that the heat flow at the ends, okay, at the boundary is always 0. Okay, that's what we have considered. So right now in this condition, okay, when we have non-homogeneous boundary condition, so this part will be missing. This will not be 0. Okay, that means heat at the ends will not be 0, rather it will have some value. Okay, the rest everything will remain same, and that's our initial condition. And we got 1, 2, and 3 conditions for this equation. Okay, so this is our problem. Now, how can we resolve? So here I have a method, okay, which will not help you to solve the problem actually, but it will help you to simplify the problem, and then you can solve by your irregular method that you have seen in my previous videos, how to solve heat equation. Okay, so I'll try to keep it simple, but still stay with me. So here I go. So we'll take help of a transformation, and which I have, and I give using this. Let's say the solution is given by uxt, so I say that solution is not given by uxt, rather it is given by some v of xt plus some ax plus some b. Okay, so let this be a transformation. Okay, so we have assumed that this transformation okay, will convert the given non-homogeneous boundary condition to the homogeneous one. Now, and this is basically a transformation. So what we will do, we will basically differentiate, because that's what we need. So here it's a function of x and t both. So again, it will have partial derivative with respect to x, and this will be again a, and b will be get dissolved, and that will be 0. So again, I need second order derivative is needed. So I need to differentiate it one more time. So let's say I got this, and this time even a will be 0. So I just have this much. And now partially differentiating with respect to t, because I also need del u over del t. So let's differentiate. So in that case, I have del u over del t is del v over del t. Okay, not much difference. So now this equation, okay, star equation gets modified to so what we have basically is this. Del u over del t got replaced by del v over del t, and that is equal to c, and then del 2 over v, to v over del t to 0 less than t. I'm sorry, t is not less than, and I have 0 x less than length L. Okay, and here we have v0t will be 0, vlt over L comma t will be 0, and the most important condition is to be noted is this one, initial condition. Okay, this will no longer be your f of x, rather it will be some g of x. Okay, now we will understand what this g of x is and where it is coming from. Okay, you might be wondering what I'm doing here, but this will be simple. Watch it. Okay, and its solution will be same. Okay, so just let me recall the solution, and its solution is given by this video you have already seen. Okay, if you've not seen, please go back to my playlist and find the solution of heat equation. Okay, so vxt will be summation n equals 1 to infinity dn sine n pi x over L e power minus c and then n square pi square upon L square into t. Okay, where this dn thing is given by, so let me write down in red ink, and this dn thing is given by 2 over L integral 0 to L g of x into sine n pi x over L dx. Okay, and this dn component will be substituted here. Okay, so you already know the solution now, and now what I'll do, I'll just take a simple example so that you understand it better. So in that case, I have one example. I'll not solve it completely, but I'll solve it partially, because you already know the method how to solve a heat equation, which is standard and homogeneous. So in that case, I have a problem. That is, say you got this del u over del t equals to del square u over del x square. And you have t greater than 0, you have 0 is less than x is less than 1. Okay, so here in this regard, what we have is u of 0 comma t is 2 and u of 1 comma t is 3 and u of x comma 0 is x into 1 minus x. Now I want to know how to solve this. Okay, so solution goes like this. I have already told you what is the transformation needed for this. Okay, so I'll say that let u of xt to be equals to v of xt plus this ax and plus b, and you have to force that. Okay, you have to force that v of 0 comma t is 0 and v of 1 comma t is 0. You have to force this. Okay, so according to this condition, our v will change. So basically, we are not shifting the problem or we are doing anything. We are just saying that when u of 0 comma t is 2, u of 1 comma t is 3, then u of x comma 0 is this. So in that case, what will happen if I put v of 0 comma t is 0, v of 1 comma t is 0 equals to 0, then I will have a new function. Okay, new initial condition that will be given by, we will see. Okay, what it's gonna be. Now, so let's consider the solution. So since now I'll write little small one, so that is v of xt plus ax plus since u of 0 comma t is 2, so u of 0 comma t is 2, substitute here. So u of 0 comma t will be equal to v of 0 comma t plus this a quantity will be 0, so multiply by 0, and now we have forced that this quantity has to be 0, so u of 0 t is 2 and this quantity is 0 again, this is 0 and plus b, so we get in that case b equals 2. I also have another condition which I'll find here, and it says u of 1 comma t is 3, so I'll substitute here. So I'll be getting u of 1 comma t will be equal to v of 1 comma t plus a plus b. So u of 1 comma t we have given that it is 3. Okay, so no harm in substituting here, and this quantity we have forced to be 0 and plus a, and b already know that is 2. Okay, so a will be equals to 1. So we now got the equation to be uxt equal to some v of xt plus a is what, 1, so x plus b is 2. Okay, so our goal is to find out this v, and just a moment, and I need u of x comma 0, so that will give me v of x comma 0 plus x plus 2. U of x comma 0 we are given, it is x into 1 minus x, so it is x into 1 minus x will give me x square, right? And that will be v of x comma 0. Okay, this is what we need. Okay, this is what we need. So v of x comma 0 will be here, and then I have x plus 2. Okay, and with some cancellation thing, I'll be getting this x and x getting cancelled, and I'll be getting v of x comma 0 equals to just minus x square minus 2. So minus x square minus 2. This is I got v of x comma 0. See, the initial condition is now changed with some another function. And our goal is now to work with, so our problem is now modified to del v over del t equals del square v over del x square. 0 is less than x is less than 1 and t is greater than 0, with the condition v of 0 comma t is again 0 and v of 1 comma t is 0, and we got v of x comma 0 equals what? Minus x square minus 2. Okay, so minus x square minus 2. Okay, and now you know how to solve this problem. So the solution to this problem, so let me write down the solution again. So I'll start from here so that I finish it in line. That gives me n equals 1 to infinity dn, then sine of n pi x over l e power minus c times, okay, n square pi square upon l square to t, and let me write down here c. Okay, here c is there, but in our case c is 1, so I'll mention it. And again I write down this dn thing to be given by your dn is 2 over l integral 0 to l. Now this part will play the role. Okay, so this is our g of x basically. Generally we make mistakes while solving the problem. We consider our earlier f of x, but that's not the case because we have to consider this g. Okay, g of x to be considered here in our case. We have this c is again 1 and l is also 1. So I'll just write down the problem and give it to you and leave it as an assignment, because I have already solved such problems, so you can simply refer those videos. In case you have any difficulty or you want me to solve in another section, just drop a comment here. I'll see that. If majority of you want, then I'll solve. So now here it is. So v of xt will now be n equals 1 to infinity and dn. I have sine n pi x, because l is 1, so e power minus c is also 1, so it will be just simply n square pi square t. All right, and this tn will be given by 2 over l. I don't need over l. I don't need, so it will be just simply 2 to 1, and then g of x is minus x square minus 2. I think this is what I know. Yeah, minus x square minus 2. That's correct. And then into sine of n pi x dx. So all you need to do is just find out this dn, substitute here, and that part will give you vxt. Once you found vxt, just substitute here, keeping everything intact. Okay, and that will be your uxt, because you want to find the solution of uxt. Okay, not v. This is the transformation which you are doing. That's why I found a and b. Okay, so the complete solution will be given by this vxt plus ax plus b. Okay, this will solve our problem. Right, so the remaining part you can complete. And the interesting part would be to solve a non-homogeneous heat equation. Okay, so whether I'll solve this, a non-homogeneous heat equation. How to handle it? So this equation is given by del u over del t equals c times del square u over del x square plus some non-homogeneous thing, that is fxt. Some function will be there. It will no longer be 0 now. Okay, and rest everything will be same. So you are given that an initial condition is also needed. So this condition I'll denote by, since I've used f, so I'll say this is phi of x, and now I need two more boundary conditions. So u of 0 comma t will be 0, and u of l comma t will be equal to 0. And here you have 0 is less than L and t is greater than 0. Okay. That's how a non-homogeneous heat equation looks. So its solution is given by, so let me write down the solution first. And the equation is a little, I mean, it looks dangerous, it is not. Okay. So please consider it, and don't lose hope while writing this equation, because it looks tough, but it is not. N equals to 1 to infinity Tn into sine of, see, even in homogeneous part, even in non-homogeneous, the homogeneous part is included. Okay, the solution is included. This is what you have already solved. Okay, only this extra term will come. And what is that extra term that we have to take care? Okay, it is given by this. So I'll write down in red. Okay, watch it. So it is n equals 1 to infinity. No more dn now, just this quantity will come. Okay, sine of n pi x over L. And then the quantity which I have here will now be under the integration within 0 to 2. 0 to t, I'm sorry, not 2. And then e power, no more minus sign, it will be just c. And then n square, pi square upon L square, and no longer t, it will be some s minus t. And then I will have here fn of s ds. Okay. Don't worry, each and every term will be narrated so you understand better. All right. Now just let me write down what is dn and fn thing. Okay. So dn is same, which you already know. Okay, it is again 2 over L, integral 0 to L, and then phi of x into sine of n pi x upon L dx. Okay, so we have given dn equal to 2 upon L, integral 0 to L, phi of x into sine n pi x upon L dx, and this fn will be, this will come out as a function of t for sure. Okay, this will come out as a function of t. But why I have written here fn of s? Because the integral limit is also 0 to t. So in that case, to remove the confusion, I have taken s. Otherwise, it is just into t only. Okay, so 2 over L, then integral 0 to L, this, and this t will be coming from this non-homogeneous part. Okay, keeping everything intact. All right, so we are not done. So rather, we will consider solving a problem instead of wasting more time over understanding the entire theory behind it. Because this, see, this non-homogeneous heat equation is mostly appears in GATE or some other higher examinations. Sometimes it has it may appear in CSIR net or probably in your DU exams. Mostly it appears in GATE. I'll solve you in the 2020 question also, the non-homogeneous. So whether we consider an example here. So example would be that you have del u over del t equals del square u over del x square plus I have got e power minus t into sine 3x. This is what I have. Now we will solve it. So hold a second, I just forgot to write the conditions. So u of 0 t I have 0, nice one. And again I have pi comma t equals 0. Okay, pi is my all-time favorite, because you might be wondering why my favorite is pi. So I know that if length is pi, I can simply get this pi and pi getting cancelled. And that gives a nice equation, which is quite simple to write. And ux0 is my sine x. Okay. So we have to make a habit of writing the solution every single time so that we are used to it. Otherwise, when you look at it at first glance, you will think that this is quite tough and you may ignore it. Or you will consider solving the next problem in the exam better. Okay. The solution is given by, uxt equals summation n equals 1 to infinity tn sine n pi x upon L e power minus c n square pi square upon L square into t plus summation n equals 1 to infinity sine of n pi x over L to integral 0 to t e power be just c times n square pi square upon L square. It will be my s minus t, and then here it will be into fn of s ds. Okay. That's how the solution looks, and we will now first simplify it. Okay. So here in our case, c is, so there is no constant, so here it is 1. So c is 1, and we are worried about the length, so we see that it is from 0 to pi. Okay, so here L will be pi. Now this equation gets simplified, and we will write down the simplified equation. So uxt will be just simply n equals 1 to infinity dn. This pi and pi gets cancelled, so I just have sine nx. This pi and pi gets cancelled. L was pi. So here I have just minus n square then t. Okay. So life is simple now. And then plus integral n equals 1 to infinity. Again, I'll be having sine nx, then integral 0 to t. E power c is again 1, n square. It will be simply n square into s minus t, and then fn of s ds. So our goal is to find out dn now, which you can easily find by using this formula. So 2 by pi, L is pi, and integral 0 to pi. Okay, I have my f of x into sine of, it will be simply nx. Okay, so let us solve this. So give me 0 to pi, integral 0 to pi. What is my phi of x? Phi of x is given by this equation. Okay, so remember you have to differentiate what is your phi. Okay, so the initial condition is given by phi, and this non-homogeneous part is your f of xt. So in this regard, we will say it is simply phi of x is sine x. Yeah, so it is sine x into sine nx dx. Now we already know that this equation exists only when this will give you a particular value only when n and this quantity right here will be same. And in case you are wondering what I'm saying, then it is 0 to pi sine mx into sine nx. Okay. This is equal to 1 only when m is equal to n. Otherwise, it is 0. When m is not equal to n, it is 0. So we know that for which value it will exist. Only for 1, only when n equals to 1. So basically, I will not be getting any dn's except 1. So I have d1 will be equal to 2 by pi integral 0 to pi sine x into, it will be just sine x dx. So that will give me 2 by pi, and this integral that will give me pi by 2. Instead, just a moment. I think I made a mistake. It's not 1, it's pi by 2. It is pi by 2. For rest of them, it is 0. So this integral I got pi by 2. So this pi by 2 and this pi by 2 gets cancelled. I get simply 1. Okay. So I got d1 to be 1, and so I'll say that dn is equal to 0 for all n which are greater than 1. Okay. Because I have only d1 equal to 1. Rest of them are 0. Okay. Now my job is to find out this fn. So fn of t will be again integral 0 to pi 2 by pi integral 0 to pi. What do I have is phi of x. No, it's f of xt, right? So sine of x into e power minus, what do I have in the homogeneous part? It's e power minus t and sine 3x. So e power minus t and sine 3x dx. Now the job is to keep e power minus t outside completely, and I'll be left with again the same thing. So the problem here, if you understood earlier, I think why I forgot to write here n, sine nx, not x. Okay, so now you know that this quantity fn of t will be only defined for f3, correct? Because n equal to 3, then it will be pi by 2 this quantity, rest, while otherwise it will be just simply 0. Okay, so f3t will be equal to 2 e power minus t over pi integral 0 to pi sine 3x. So basically it will be squared. Okay, and that will give me 2 by pi here, and e power minus t is there, and then again it will be again pi by 2. So this gets cancelled, you get e power minus t. So I have f3t as a function of t, e power minus t, and rest of the fn's are 0. Okay, for all n excluding 3. Okay, so we are now ready to substitute in this big equation. I'll call it hash. Okay, rather not hash. It's better if we call this equation to be hash because this is more useful. Okay, so from hash, what do we have? From hash, I'm getting u of xt equals, see, I have only d1, right? I've got only d1, rest of them are 0. So basically this term, if I open, I'll get d1 sine 1x e power minus 1 square t, d2, and since I know that d2, d3, d4, all of them are 0, so I'll just write down only one term, d1. Okay, so it will be d1 sine x e power minus t, and then this will be 0 e power minus t, and while rest of them it will be 0, so I'm not writing. And here I have only 3. Okay, correct, because I've got only fn 3, so I open this term only for n equals to 3. Okay, because for rest of them it will be completely 0. For rest of them it will be completely 0 because fn of 3 becomes 0, so this will make this entire integral to be 0, and if this entire integral is 0, it will make this the term in the series to be 0. So it will be opened only for the quantity where fn exists. So this exists only for 3, so I'll open it for 3. So I'll be getting here sine 3x into e power, oh I'm sorry, integration. So integration 0 to t e power minus t or n square t, e power minus n square into s minus t. So e power minus 9 times 3 square, right? So it will be 9 s minus t into f3t. Now let us substitute. So d1 is 1, so no need to worry about anything. So it will be simply e power minus t plus sine 3x will remain as it is, and then integral 0 to t, it will be e power minus 9s and plus 9t, and f3t is e power minus t. I think I made a mistake. It's ds. Okay. It will create a confusion around f3s ds. So it will be, instead of this, it will be s e power minus sts, because I got here e power minus t, so I need here e power minus sts. So goal is now to do this e power minus t into sine x, and plus sine 3x will remain here, and I can take this since there is no rule of t here, so I'll take e power 9t completely outside, and it will be e power I'm again making a mistake. Just a moment, let me check it. So there is no minus, and I have unnecessarily put here minus. It is switching the game, so let's get rid of this minus sign, and it will make it minus. Now it will be minus 90. Yeah, that's correct, because in heat equation you can never get a quantity which will go to infinity. Okay, so that's when I recalled the heat equation. When you have as limit x t goes to infinity, so this your temperature, okay, this must go to 0. Okay, so here I was getting e power 90, so that's why I got suspicious why I'm getting this. Now e power 9s minus s will give me e power 8s, okay, ds. Now and simply write down e power minus 9s and e power minus 90. Instead of writing this sine 3x, I'm writing sine 3x, and this is what you had been playing through 12th standard. So it will be e power 8s upon 8 between the limits 0 to t. Between 0 to t. Okay. So you get e power minus t sin x plus e power minus 90 upon 8 into sin 3x, and this one right here will give you e power 8t minus 1. This can even be simplified further, and 8 minus 9 will be minus 90. And you can simply balance it the way you want. Okay, the final solution is this. And with this same idea, you can think of solving some more problems. And since I'm liking shorter problems, so right now I'll take one more concept, which is frequent in most of the exams. That is heat equation with infinite string. What is that? Let's see. Let's tell you over del t equals c del square u over del x square. Earlier, our length of the string was fixed. It was between 0 to L somewhere. Right now, everything will be missing. Okay, temperature at the both the ends will not be given, and this limit will be this string will be an infinite large string. Okay. It will be an infinite large string. Okay. So how do I solve that? And you are given just one initial condition. Okay, ux0 will be equal to some f of x. How do I go with this? So I'll write down the solution, which is quite easy to solve. Okay, if you look at the solution, it is uxt equals 1 upon under root 4 pi ct. Okay, then integral minus infinity to infinity e power minus of x minus s upon this x. It's not a distribution thing, otherwise people will start imagining this is simple, this x. Okay, so x minus s upon under root 4. Remember, this entire quantity will come here except pi. Okay, and this will be squared now times this f of s ds. Okay, so this is the solution of infinite string. Okay, now we will consider a problem from GATE 2020. So let me write down the problem. So this was the question which appeared in GATE examination 2020, question number 40, saying that let K be a function from r cross 0 to 0 comma infinity to r be a function such that the solution of the initial value problem is, and just by looking at this line, should be able to recall that it's a heat problem, okay, with infinite string, right? U of x0 equal to some f of x, and they even have given the solution that u of xt equal to, see, most of the students got tensed because of this limit integration over r. Okay, so this is not a big thing. It's basically integral minus infinity to infinity, and it's x minus y. So if you have watched my video, then you must be knowing that it is x minus s. Instead of y, I'll be writing s. So let me change the notations here. So x minus s comma t, okay, into f of s ds. This is what they are saying. Okay, the kernel is a function of x minus s and then t. This is what they are saying. Okay, and they want here f can be anything. It's for any bounded continuous function. Then they just want this integration over minus infinity to infinity. What is the integration of this kernel? Okay, kxt is what? So let us solve. Okay, so the solution goes by this. Just let me write down the problem here. What they're given. What is the data given to us? There is no data in the problem. Okay, no problem. So rather what we will do, we'll just write down what they have given. So uxt equal to that integration over r, I'm writing as minus infinity to infinity. And instead of y, I'll be using s. Okay, so I have k times x minus s comma t into f of s ds. This is the solution they have given. All right, and now they are asking this, okay, kxt dx. That we will see later, but first let me complete this thing. Okay, so comparing with the solution, of heat equation with infinite string. So in that case, you get, just let me write down again, uxt was 1 upon under root 4 pi c t, integral over minus infinity to infinity e power minus of, what is there, separate in here, minus of this entire quantity. So that is x minus s upon under root 4, only pi will not come, so 4 ct square and then f of s ds. So if you compare this thing, okay, call this equation 1 and call this equation 2. So comparing equation 1 with 2, what do you expect? You simply get this k factor, k of x minus s comma t, k of x minus s comma t to be equals, so I have to consider this constant also inside the picture. Okay, so I'll be getting 1 upon under root 4 pi ct and e power minus of x minus s upon under root 4 ct square. Okay, so this is what I'm getting, and now I have to get rid of this c. What is this c? So in that case, it is 1. So let us simplify. So k of x minus s comma t will be equal to 1 upon under root 4 pi t. Okay, and this point is simply 1. Now e power minus of x minus s upon under root 4 pi will not come, c is 1 t. Okay, square. Right, this is what I got, and what they are asking is I have to integrate minus infinity. I have to integrate this k of xt. So let us first simplify the problem and bring it to kxt instead of kx minus s. So when you have x minus s, you are getting here x minus s. So what if I do this? So I'll be getting k of xt is equal to 1 upon under root 4 pi t integral e power minus of, it will be simply just x square upon 4t. Simply just x square upon 4t. And now I want the integration. So integral minus infinity to infinity k of xt dt. Dt or dx, what do they want? Dx. Okay. Of course, t cannot be here because t is always from 0 to infinity. Okay. So let us integrate now. So minus infinity to infinity 1 upon under root 4 pi t e power minus of x square upon 4t dx. Okay, and to consider this, I'll simply consider taking all the constants out first. So 4 pi t and integral minus infinity to infinity e power minus of x square by 4t dx. And for those who love gamma function, they must be knowing how to handle this. How to handle this point. I don't find this interesting, so I'll just substitute something. Okay, so consider integral minus infinity to infinity 1.4 pi kt. I forgot. So I got under root 4 pi t. What is that? E power minus of x square by, what do I have? 4t dx. So 4t dx. Okay. Now it's time to make a substitution. So the substitution part will be done on the right hand side. So I'll put x square by 4t to be equal to some z. Okay. And my goal is to find out dx, and see there is no change in the limits. Okay, so there is no change in the limits. Okay. Hold a moment. No. I guess I made a mistake, because if it is x square, so minus infinity to infinity will be 0. Wait. I need to think about another substitution. Rather, I was happy with this thing. Minus x upon, what was that? 40, right? So it was under root 40. So in fact, this thing was earlier better. 40 square. Okay, so put this entire quantity. So x upon under root 40 to be equal to z. Now there is no effect on the limits. So as x tends to minus infinity, your z will tend to minus infinity, and when x tends to infinity, z also tends to infinity. Now you have to worry about this dx. So dx, differentiate this directly and take this quantity on the right hand side, 40, then dz. Now let's get back here. So we are given full freedom to do this. 4 pi. Let's see. Just a moment, I'll play a game here. It is 4 pi t, so rather I'll write on this under root 4t into under root pi, and then minus infinity to infinity e power minus, it will be z square. What is dx? It's simply under root 4t and then dz. And I got a nice facility of cancelling this term with this term, and this one will give me 1 upon root pi. Okay, and now minus infinity to infinity e power minus z square dz. So this quantity right here is called as Euler-Poisson integral. It is directly a root pi. For those who don't know, for them I'll prepare another video. I'll make another video. Okay, or you can simply equate even with the gamma function. Okay, or you can equate with gamma simply. Equate with gamma function. That will ease your job. And those who don't know, just remember that its value is root pi, because integral 0 to infinity e power minus x square dx is root pi by 2. This you derive by error function. Okay, error function of x. This one you can derive from there. And if it is from minus infinity, this 2 gets cancelled. Okay, because it is 2 times. So you get root root pi. Okay, so this will be 1 upon root pi into root pi. So this root pi gets cancelled. This entire integration becomes 1. So answer is 1. So thanks for watching. And in the next video, we will be coming with non-homogeneous problems and heat equation with infinite string problems. Okay. Thanks for watching. See you in the next video.